Hello, my name is Gábor Németh from Co2 Consulting Ltd. from Hungary. Let me introduce a new certification scheme for dwellings, which name is TripleA-reno Combined Leveling Scheme. This scheme has been developed by Co2 Consulting Ltd. as part of the TripleA-reno project. The project is an H2020 project supported by the European Union, and its goal is to facilitate decision-making on deep renovation for end users of residential buildings. As part of the project, the aim was to create a combined leveling scheme which includes energy performance, indoor environmental quality, and well-being indicators. So these indicators were gathered according to the purpose of the project, and they focus especially on energy performance and comfort features of dwellings. During the work, the main existing certification schemes were studied, such as LEED, BREEAM, DGNB, WELL, EPBD, and Levels Reporting Framework as well, in order to determine the relevant indicators and requirements. During the project, we made several interviews. Many stakeholders and occupants emphasized that knowing performance-based data before and after a renovation project would be very useful to know, because currently the lack of knowledge on the renovation is a significant barrier to implement renovation projects. So we hope the TripleA-reno Combined Leveling Scheme can provide clear, evidence-based data on energy performance, indoor environmental quality, and well-being. On the basis of our assessment, a set of energy performance indicators, qualitative well-being and IQ indicators, and measured well-being and IQ indicators were aggregated to establish a combined leveling. The template was developed in Excel format, so I'm going to share my screen now and explain the parts of the leveling. Here you can see the combined leveling template on energy performance, indoor environmental quality, and well-being. This is a one-page long template, as you can see, so it takes not more than a few minutes to fill out if you have all the necessary data. You have to fill out the white background cells. Now let me show you how it works. In this line, you have to give the name of the building or building unit and the date of the assessment. Next, you have to select the season of the measurements that you made in the building. You can select from this drop-down menu the heating, the cooling, or both heating and cooling season. In this part, you can see the results of the combined leveling, but let me come back later to this. In this section, you have to provide all the energy performance indicator of the building or building unit. Firstly, you have to give the energy class of the building or building unit. This is aligned with National Energy Performance Certification according to EPBD. So, in this column, you have to give the energy class, the A, B, C, D, etc. The second one is the calculated total primary energy use in kilowatt-hour per square meter year. This is also coming from the National Energy Performance Certification, and you have to give here the calculated value. The total primary energy consumption is maybe too difficult to understand for lay people, and it is also true that there are big differences among primary energy factors of different energy sources. Therefore, it makes more sense to show also the delivered energy use, and both the calculated delivered energy use and the measured delivered energy use. Because the calculated delivered energy use is an objective way of evaluation of the energy performance. However, the measured delivered energy use is a very useful indicator, especially in case somebody would like to monitor the energy consumption, for example, before and after a deep renovation or any kind of intervention. And it is also able to evaluate the behavior of a selected residential building or building unit. So, in these cells, you have to give the calculated delivered energy use separated for fuel, for electricity, and for district energy in kilowatt-hour per square meter year. And you can see here the sum of these calculated delivered energy uses. In these three cells, you have to give the measured values. It is based on the measurement that you made in the building, or you can import it from the energy base. And you can see here the sum of these values, the total measured delivered energy use in kilowatt-hour per square meter. The fifth energy performance indicator is the share of renewable energy sources in the building or building unit. So it's a percentage. The renewable primary energy use is divided by the total primary energy use. Here in this example, it is only 2%, so there is enough room to increase it. So it can be a motivation for end users if they see that it's very low, so it can be increased to protect the environment and to use more renewable energy. And the last one is the area weighted average thermal transmittance. It is very useful when you compare building structures as a whole before and after a renovation, or when you compare energy characteristic of building structures of two different buildings. So these are the energy performance indicators that I presented to you, and these express the energy characteristics of the building one by one. Therefore, aggregating them into a single energy indicator is not recommended. So these are shown to the end user one by one in the results section. As regards the qualitative well-being and IQ and the measured well-being and IQ, the output of the labeling is one class. That could be excellent, good, acceptable, weak, or very weak. This is because we would like to ensure the easy understanding of the labeling of these kind of parameters, the measured and the qualitative parameters. But of course, in the labeling, you can see the details of the results, the sub-indicators. So one can see which parameters are good and which should be improved. As for the qualitative well-being and IQ indicators, I think this is a very important part of the labeling, because the well-being and the indoor environmental quality very much depend on the features of the technical building systems. So these indicators are the control of the heating system, control of cooling system, the fresh air flow, the air tightness of windows and doors, the exterior shading, the radiant heating and cooling system, and the radiant temperature asymmetry. We gathered those essential parameters of the technical building systems, which on the one hand influence the IQ and the well-being of occupants in residential buildings, and on the other hand, these can be improved by renovation. So the first one is the control of heating system. It's a very essential indicator, because the control of the heating system influences very much the well-being of occupants, and this is because they want to set the indoor temperature according to their specific needs. And if there is central temperature control, for example, there is very few possibility to achieve the desired value. But if there is room temperature control, it's much better. So this can be seen here in this table. If you choose the room temperature control, you achieve the maximum points. If you choose the apartment control, this is only 10 points, and central is 5 points, and if there is no control, then your project achieves 0 points for this indicator. And for example, if there is no heating system, for example in the Mediterranean countries, Spain and South Italy, and then there is no theoretical maximum and there is no achieved points, of course. And the labeling of these qualitative parameters is based on the theoretical maximum points and the achieved points. So this is what we do. So if there is room temperature control, then you will achieve a much better result. If there is central control, then it's 58% weak. So the methodology is this. So you have to choose the right answer, the right characteristic of the technical building system. Then the Excel template calculates the points and the result. So here you can see the answers for the fresh air flow. This regards for mechanical ventilation system. So you have to calculate the fresh air flow per number of occupants and see whether is in the category 1 or 2 or 3 in the EN 16798 standard. Regarding the air tightness of windows and doors, there are 3 possibilities. You can check the quality of the doors and windows at the on-site visit. So if there is poor air tightness that you see, that you can select it, and this means that 0 points will be given for this category, for this indicator. But if there are good air tightness or medium air tightness windows, the project achieves more points for this indicator. The next one is exterior shading. You have to check whether the percentage of the exterior shading is 100% or lower, and you have to select the right percentage. For example, if it's 68% of windows from east to west have exterior shading, then you choose this one and your project achieves 6 points for this indicator. Next one is radiant heating and cooling system. It is also an important indicator because these systems have the potential to provide better thermal comfort than conventional systems. So you can check whether there is more than 50% of the conditioned floor area has radiant heating or cooling system, then you can select this answer. So you achieve the maximum points, or if it is below 50%, then it's 0. This kind of evaluation is adopted from the well labeling scheme. And the last one is the radiant temperature asymmetry that's included in most of the reviewed labeling scheme, I have to tell, and it is also included in the TripleA-reno combined labeling. So you have to check your building or building unit, and you can select here which is the category according to the standard, and then you select A or B, then you achieve 10 points, but the first C is 0 point. And you can see here the bad result if there is such systems that I selected, but if I select better one, yes, then the final result for the qualitative indicators is 68%. Okay. So these were the qualitative well-being and IQ indicators that I presented to you. These provide feedback to the end users on the technical building systems and its capabilities from well-being and IQ point of view. However, these don't give information on what figures are realized in the analyzed residential building or apartment. Therefore, these on-site measurements are needed to evaluate the realized conditions and providing information to the end user which parameters are good and which could be better in order to improve IQ and well-being. The measurement place is the living room. The measured parameters are operative temperature in the heating season and/or operative temperature in the cooling season, and relative humidity, CO2 concentration, TVOC, formaldehyde, and particulate matter. Concerning the temperature and the CO2 concentration, the measured figures have to be compared to the standard, to the EN 16798 standard. Concerning the relative humidity, the measured figures have to be compared to the comfort range, which is from 30 to 70%, and you can select here the right answer. And concerning the TVOC, the well-being limit is 500 microgram per cubic meter. This limit was taken from well and lead labeling schemes. And regarding the formaldehyde, the limit is 100 microgram per cubic meter. This limit was taken from the WHO. Concerning the particulate matter, the limits can be seen here, and these were taken from the well labeling scheme. So here in these white background cells, you have to select the right category for your measured values. And after you are ready, based on the labeling results, you can give recommendations to the end users here in this box. And at the bottom of the template, you can insert pictures of the building unit. So, thank you for your attention. I hope this video can be useful for understanding this combined labeling template. And if you have questions or if you are interested in to use this combined labeling template, then please don't hesitate to contact us. Thank you.